G'day there, you're watching the Aussie BIM Guru. Today I've got a pretty hotly requested tutorial which is how to do a fit out test based on an existing layout for COVID-19 separation using Dynamo. So I'd like to thank Cyril for helping me with this in particular. I actually went to the Dynamo forums because, believe it or not, the Aussie BIM Guru sometimes needs help as well. And he helped me out with a really lovely Python script that really helped unlock this workflow. I tried building one myself and hit a few roadblocks along the way. He had a very different approach to it, and it's led to building a custom node as a result. I'd like to also thank the people that wrote this article about occupancy testing using Dynamo. They've essentially went about the same challenge that I have and largely also inspired me to build my own take on it. But I did find, I guess, that their workflow was a little bit longer and a bit more exhaustive, and I did see some opportunities to optimize and streamline the script. You can see down below the script is much smaller. There's a couple of custom nodes which help simplify the process, and I just felt the way that the process worked probably needed to be simplified a little bit as well. Having said that, they do a couple of extra steps which I don't do. For example, initially they group all the chairs by room. Personally, I didn't really think that step was necessary, but maybe if you wish for it to be, check out their article and you can see how they did it. So why have I made such a delay to make something that's probably quite relevant right now? Well, I really do respect that a lot of you, I know personally, have been affected by what's going on, or your family. Out of respect for this, I have delayed this tutorial because I did know that it probably wasn't appropriate to talk about this on a place like my channel at such a time of difficulty. So I have waited at least until countries have been a little bit more under control. Having said that, I wish you all good health, and I hope that if any of your family or yourself aren't in good health, that you have a speedy recovery. So the goal today is that we're going to find the maximum number of seats we can fill in an existing office layout based on a 1.5 meter separation between chairs. In this case, we're going to also report back some basic metrics such as efficiency of seating arrangements, and we'll also visually show the results as well. So the method is relatively simple in principle. We're working with a 1.5 meter separation. So the first thing we'll do in our script is actually collect all the elements by whether they are within 1.5 meters of each other. We're going to break these down into what we call clusters. So this, for example, is a cluster of chairs. We're going to then look at this cluster by all of its seats. And for each seat, we're going to run a study. We're going to begin at one seat, and then we're going to check every seat around it. And if any seats are within 1.5 meters, we say that seat can't be filled. We then move on to the next nearest seat that is outside 1.5 meters, and we rinse and repeat that process. So this is where Python becomes really important, because if you're repeating a process, you're essentially looping. This is something that whilst Dynamo can technically do it, it's much easier to do in Python. So in this case, this is where a lot of the custom node comes into play. So we will be using a few custom nodes here. I'm using a couple of nodes from the Rhythm package, specifically the simple user message at the end, and also one of my favorite nodes from Rhythm, which is to get a parameter by name or instance. So if the parameter is not an instance parameter, it'll still find it anyway. I use this node so much, it's amazing. And I'm using a few nodes from my own package, Crumple, as well. I recently added the nodes for this test to the custom package on the package manager. I believe the package might be at 1.0.6 at the time of recording this, so if you've got a later version, that's okay. But essentially we're using two nodes. We're using elements by minimum separation and elements group by proximity. I'll be using my if then else as well, just because it behaves a little bit differently to the way that the if then else in Dynamo behaves. My versioning is Revit 2020.2.2 and Dynamo 2.3.0. Anyway, without further ado, let's just jump right in. So I've just got a little testing model set up. You could have an actual office fit out. What matters is that you're going to want to be able to filter all the seating elements in your model by something that they have in common. So for example, all of my chairs have a keynote, and that keynote always begins with f.cha. You could use description, you could use family name, type name, anything really, as long as it has it and it's common to these elements, because we're going to take these and use these for our test. Anyway, I'm going to jump into Dynamo, and it's important to actually, before you start, that maybe make a few different arrangements of chairs. Make a pair, make a lone chair, and make a couple of rooms maybe, and a few clusters. And make sure the chairs are within 1.5 meters of each other. Don't put in a safe, compliant layout, because obviously that would not really give the test any meaningful results. So let's begin. So the first thing I'm going to do is collect all of my chairs. So I'm going to get an all elements of category in view. And I'm going to take category and I'll just take categories drop down. You could use category by name if you want though. I usually use that. So we're going to take category, and for our view, we're going to get a current document and an active view. And we're just going to take the current view that we're looking at, which is our floor plan. So that makes sure that if you're just doing one floor at a time, that you only have to open one level at a time. If you wanted to test an entire like tower of offices, I still recommend going about this one floor at a time. Otherwise, the logic of the script will change a little bit. Anyway, from here, we should now, if we run this, have all the furniture in the current view. So we're going to be filtering this. So I'm going to use the element, I'm going to get the element type parameter by type or instance. Usually I just look for type or instance to find this. And from this, we're going to obtain a parameter by name. So in this case, I'm going to make some strings because we're going to make this a Dynamo Player compatible script. So the first thing we need is our filtering parameter. So what are we using for our parameter? So in this case, I'm going to say that my parameter is going to be, we could do family, or we could do keynote. I might just do keynote in this case. I'm then going to copy this, and I'm going to say parameter value contains. So I'm naming these so that we can use these in Dynamo Player. And I'm going to put in my default values. And then I'm also just going to add a boolean to say, are we ignoring the case of the value? Because sometimes you might want to, sometimes you might not want to. So these are 3 inputs. So at this point, I can just say use input by right-clicking on these. And then I can begin working with these. So I'm going to connect my parameter name here and run this. And I should get a list of all the keynotes of my furniture. We can see there are some of them that aren't chairs, so we need to filter these out. Now I'm just going to, in this case, I believe this should already be in the form of a string actually, so this should be fine. But sometimes these values might not be a string. So you may need to convert these into a string, just in case you're interrogating something like a numerical parameter. From here, I can get a string contains node and check if those strings contain that value and are we ignoring the case. We should then get a list of booleans or trues and falses that we can filter these elements by to isolate just our chairs. So I'm going to, in this case, take my list of elements and filter them. So this is a very common workflow in Dynamo. You've probably seen me do this a lot of times already. But now we just have our chairs and we've excluded our pinboards and our tables. So typically at this point, I would block this off as a portion of the code. Okay, we're moving on to the next step. Now it gets a little bit more interesting. So we need another input now. This is going to be a number. And in this case, this is going to be the minimum separation. So we'll just rename that. Make it an input. And of course, by default, we'll be using 1500 or 1.5 meters. Now we're going to use the first custom node from my package here. We're going to use element group by proximity. I might need to search for this in the browser potentially. Oh, there we go. So we're going to take our elements, our chairs, and we're going to group them based on whether they're within 1.5 meters of each other. Now if I run this, you should get sublists, which contain all the elements grouped by whether they're together. Now this node is actually relatively simple inside. It just contains a set of Dynamo nodes which run a few steps, but essentially what we're doing is we're finding the center of the element, we're ignoring the Z value, so we're just always working on a common plane, and we're making a circle at that point. We're then turning it into a solid and joining them all together, and then intersecting them with the XY plane. From here we can assess all the outlines of these clumps of solids, which are now surfaces, and then we can check which surface we've just cut through originally intersects with the centroid of each of those elements. From there, we can regroup them based on these intersections by finding the index of where they intersect. So it's a relatively straightforward workflow, but the result is that you will get these elements grouped by how close they are. Now, this is probably a useful node beyond this workflow. I've used this for a couple of other things as well, so hopefully you find that useful as well. Now we're going to get the elements by minimum separation. So we're going to get elements by minimum separation, and we're going to take, in this case, our elements, and for the, well, it's called count, I might fix that. But if you connect the minimum separation to the second input, it'll run a little Python script, and now you're just going to get only the elements that do work in the best possible configuration. Now this node's a little bit more complex. It contains a Python script provided by Cyril, and I've just done a tiny bit of change and cleanup to it and added some references to the Dynamo forums. But it's a relatively complex script. I'm still learning about how it works. It's quite sophisticated, but essentially it does run every possible scenario for each cluster or sublist. And the result is all the elements that do comply. Now I'm going to take all these elements and just flatten them into a list of elements. And we're going to have to find the ones that didn't make it. So we're going to find the elements that don't occur in the original list of chairs. So we're going to flatten the entire list of chairs as well. We're also going to need to chop our results back into a logical order. So in this case, I'm going to count the length of my original size of clusters, just so we can break them back down after. So in this case, we now know how many chairs are in each set of chairs. I'm then going to run a list contains, because we want to find out if the original list of chairs, do those elements contain, are they contained in the compliant list? So in this case, we're going to work with this list at level 2, so that we're going to check the entire list of compliant chairs, and then we're going to check every chair in the original set. And we should get a true or a false if we set this to longest lacing for each chair. And now we can see which ones do occur and which ones don't. At the moment, we can't really apply this in the same way to our original list. So what we do need to do with that is we're going to chop that list. So we're going to take our list and our lengths. I'm going to run this, and now we're going to break down that original list based on our chair clusters. So now we can separate those based on their sublist arrangements. I'm going to get a filter by Boolean mask, and using these parallel mask lists, I'm going to feed this all the way back to my original set of elements. So I might just move these down a little bit. And as a result, we should now have arranged clusters, and the in list will be the chairs that were in the resultant successful chairs, and the out list will be the ones that weren't. And they're all still arranged by cluster if you need them to be. So at this point, we can now really just assess our successful and non-successful chairs. So it's up to you whether you have a use for keeping these clustered or not. In this case, I'm just going to flatten them anyway as two sublists, because I don't really need them to be together. They don't really serve a purpose in this case. But if you have a use for them, that's okay. So now we should have just two lists of successful and non-successful chairs. Now we can do a few things with these. We can change their color, we can give them a comment, we can measure how many there are. We're going to do all three, just to give as much meaning to our result as we can. So the first thing we'll do is just set the comment. In this case, I'm going to get a set parameter by name, and I'm just going to be setting the comments field. Now, one reason why I choose to use the comments field is because when it's in a nested family, only a few of the parameters are accessible. In this case, comments is accessible. So I'm just going to take all these elements and just wipe their comments field clean. So I think I ran a test previously. So now they have no comment. But at this point, I can take my successful elements and my non-successful elements, and I'm just going to build a little code block. And we're going to set the field of comments, and we're going to use the values occupied and vacant. So we're going to take the parameter name as comments for both, and occupied for the successful ones, and vacant for the non-successful ones. If I run this result, we now should be able to set these parameters by name. And if I go back into Revit and just create two very basic filters, so I'll just create one called occupied. I'm going to apply it to the category of furniture, and I'm going to say comments equals occupied. I'm going to duplicate that and call it vacant, and just set up the same, but as you can guess, we're going to be searching for vacant instead. Now I can go and apply these two filters. And in this case, I could do pretty much any way to represent these. Essentially, I could maybe half-tone the vacant ones and make them red. And for the occupied, I could make them green. And now we can see that some of these aren't possible, such as this one. And we can see here we've got a few, so we can see the results we get are making sense, that we are achieving the maximum possible outcome, but we're not having any seats closer than 1.5 meters to each other. So it's a pretty powerful result. We could obviously go into 3D as well, and you could apply the same filters in 3D. Now obviously there's a few limitations here in that you would have to, I guess we could change the patterns in 3D actually. That's probably a better way to represent these. I could say occupied is solid and vacant is red. So what we've done there is essentially created a visual filter and also a comments field so you can schedule these. But we're also just going to measure these in Dynamo just to spit out some basic metrics when the test is run. So we're going to say how many seats are filled, how many are empty, and what is the percentage or the efficiency of the overall layout. So if I just go back into Dynamo, we're just going to obtain some metrics in this case. So we are going to need to count how many seats are filled and how many seats are empty. So I'm going to count both, so my successful seats and my non-successful seats. And from these, we're going to do just a few things with these. So we're going to firstly just build a little code block. And we're going to say the total number of seats equals included plus excluded. And that's just how many seats we have in total. From there, I'm going to be getting an efficiency. So I'm going to say that we're going to use the math section, and we're going to round. Now we're going to be rounding 100 times the included seats on the total. And we're just going to do this to one decimal place. In this case, I think I made a typo there. So now if we feed in the included and the excluded, and we run this, we should get an efficiency 58.3% to one decimal place. With this, we can just build a little message at the end of our script. So I'm going to again just make a code block, and I'm also just going to make a string so that I can insert the string of a new line here and there. So we're going to have firstly a caption for our message, which is going to be results. And then the message itself is going to be a little bit more complicated. So I might just move it back a little bit so we can see everything. Okay, so we're going to say firstly the occupied number of seats or the included number of seats. And then we're going to add just a of symbol, so how many are occupied. And then we're going to do of the total number of seats. Plus, and we're going to do seats filled. So we're making a little message, and then we're going to add 2 new lines, and then we're going to say percentage plus utilized. So we've got a few things to fill in here: included, total, the percentage, and a new line. And adding these all together, we should get something that looks a little bit like this. So just a little message that we can output. And we can output this using the Rhythm simple user message. And we'll make the caption this and the message that. And now when we run our study, we should get just a little dialogue that gives us some metrics that we can quickly see when we run the study. But essentially at this point, I think we should be ready to run this in Dynamo Player. The final script that I've put on GitHub will be a lot cleaner in layout than this, and it will also have just a section that does give you an option to override the color of the elements using an override as well. In this case, I thought a filter would be better to show. But at this point, I can really just close this, and we'll just go back a step before we populated everything. Actually, no, I'll do this, but what I'll do is I'll just take out the occupied vacant field. So I'll reset the comments, which means that the filter is no longer active. And I'll run Dynamo Player instead. And I'm just going to navigate to my script. And I'm just going to go to my inputs for my demo script, which is what I've just been working on. And we should have those, I think, 4 inputs that we nominated. Great. So in this case, I'm going to be using Keynote, f.cha, I'll say ignore case just for the hell of it, and our minimum separation is 1500. Run my script. I get a little message for my efficiency, and my chairs are overridden and also have data in them. So just a nice quick little workflow, and I hope that I've sort of given people something that they can use in maybe their own office if they're testing layouts at the moment, and this could be a good quick way to assess the best possible outcomes for seating arrangements based on an office at its full capacity. And from there, you can obviously relay out your office, and then you can run more tests. It's up to you. Alternatively, you could build something more complex like a generative script, which does automatic furniture layout. Now, I don't really probably have time to develop a script like that. They're quite complex, but that's probably the next step from here, and to assess things like circulation pathways as well. But there we go. So hopefully you found that that useful. And the files will be on GitHub for this as well, the presentation plus the script. So if you're not already following and subscribing, feel free to do so. I hope everyone's well out there, and if anyone's affected by this, I wish you a speedy recovery. And I hopefully will see you in future videos. Thanks. Take care. Bye.